Hello guys, good evening. How are you? What's up? Are you all right? Can you hear me clearly? Very good. Since I made some changes to the PDF file, to the slide, so I have to again upload it here. So be patient. It will be uploaded soon, I hope. And we have some cold days in Mashhad. How about Iraq? Is it cold in Iraq? I guess, yeah, hot. But in Mashhad, we really see the autumn season. Wow, 38 degrees. In Mashhad, we have 3 degrees mornings these days. 3 degrees. And yeah, it's cold. Well, let me zoom it here. Okay. Can you see the PDF file, this slide? Well, before I begin the lesson, I want to talk about this ayah from Quran. I don't know how is your relationship with Quran, but I hope you can read, you have time to read 1 or 2 pages of Quran every day, at least 1 or 2 pages. And because it is a very wonderful book, and the book that take you higher at any level, take you better, make you better. And this is ayah 22 from Surah Ra'd. Surah Ra'd, ayah 22. It's very interesting for me. One day, while I was reading the Quran, I came across this ayah. In this ayah, God mentions the characteristics of the wise people in the heaven. The wise people in the heaven. Wise people in Arabic means ulul albab in Quran. Ulul albab. The characteristics of ulul albab is in this ayah. As you can see, it's Arabic and you can completely understand this. As you can see, the first characteristics of such people is that they are patient and they pray and they help poor people secretly and openly. Sirran wa alaniya. Secretly and openly. And the last part of this ayah is very interesting for me. the last part of this ayah. وَيَدْرَؤُونَ بِالْحَسَنَةِ السَّيِّئَةِ. You know what does it mean? It means if somebody do bad to you, you forgive them, and also you do good to them. So it's not easy. I know it's very difficult, but it could be a practice for us to try to be ulul albab, you know. So I suppose if we try and if we try to forgive people and to be good with all people, so it is possible for us to be a part of such people, such wise people in the heaven. The God says they are ulul albab. So it's not impossible for me. It's possible. It's possible for me. It's possible for you. We only must try. Yeah, it's great. It's very, very nice and beautiful. It's a good pattern for us to live such ways, in such ways. Be patient and pray and help poor people and do good with people, even though they do bad with us. Well, so let me check, where were we? Where were we? Yeah, it was. Oh, what happened? This is the last slide we talked about. Yeah. We reviewed some examples of a distributed system. And e-learning was the last one. So let me ask you some questions. Who can define what is a distributed system? The definition is very important, so I expect you to memorize it. So what is distributed system? Tell me the answer. I'm waiting for you. What is distributed system? What was the definition? Have you forgot it? It's the multi-computers. So what about main concepts? ENIAC? ENIAC is not a distributed system. What do you mean by ENIAC? Using a DOS as a software? No, distributed system. I talked about it a lot last session. The part of an electronic system after the transmission system that is dedicated to delivering electron. No. What does it mean? What are you speaking about? What are you saying? I just asked you about the definition of distributed system. different systems in different locations or connected by the net. It's not accurate. It's not accurate. So let me go back to the definition slide. Here, look at this slide. A distributed system is a collection of independent computers. It's important to say independent computers. A collection of independent computers that appears to its users as a single coherent system. You must mention this concept, this important concept in the definition. Otherwise, your definition is not accurate. Okay? Please memorize this definition. Please, please. It's very important. You must know. You must know about it. So, if I want to continue giving examples of distributed system, in the next slide, I can introduce a new area of distributed systems. It's a good example of distributed system called Distributed Multimedia Systems, or DMMS. DMMS, or Distributed Multimedia Systems, is a distributed systems that, who can complete my sentence? What is distributed multimedia systems? What do you guess? Please do not copy paste from the internet, okay? Just think and tell me what you guess. What do you guess about distributed multimedia systems? By looking at this picture, you can guess something good. I'm still waiting for you. It's a system that by it can communicate and process the task or the information in a time. No. Or a specific time. No. It's not DMMS. The distributed multimedia system, as the name implies, is some systems about multimedia, okay? And it is distributed, so we have some independent computers interconnected, and we have also multimedia, so these independent machines can use multimedia. It means they can see and they can hear voice and see films. It's multimedia, isn't it? Distributed multimedia systems, in fact, tries to combine a variety of multimedia information resources by using a network into an application which is used by the client. So, as you may guess, the system is based on the interaction between the user and the application, interaction between application and user. Look at this picture, please. Here you can see a simple architecture of distributed multimedia systems, or DMMS. You can see that several multimedia resources and clients are interconnected through a network, by the network. It is a local network here. The appearance of distributed multimedia systems was about 13 years ago. It was initially about video conference, in fact. So about 13 years ago, it appeared by creating video conferences. You know what is it, video conference? You know, I'm sure that you know. And right now, at the moment, we are using a type of video conference. We are using a type of video conference, aren't we? Do you agree with me? Yes. Because if I am able to share this picture and this slide, this PDF file to you, and you can see it and you can hear my voice, it is because of DMMS, or Distributed Multimedia System. It's a type of distributed multimedia system. Yes, Skype and WhatsApp and other applications that provides video conference is categorized as DMMS. Moreover, when you are watching a football match, live football match, in fact, you are using distributed multimedia systems too. It's a DMMS too. And now I want to talk about goals and definitions in DMMS. The definition, the main goal in DMMS is simplicity, and we want and need high quality, reliable and interactive multimedia. These are our main goals. So the simplicity is as important as reliability and quality in DMMS, because it must be easy to make a DMMS, to create a video conference for users. Simplicity is important. Also, quality, reliability are important too. And here we can see a word, reliable multimedia, or you may have heard about reliable connection in network, reliable internet connection, reliable application. What does it mean, reliable, in computer science? No, it's not accuracy. It's not accuracy. Accuracy means دقت in Arabic, دقت. But reliability or reliable have different definition. Trust. Yes, something like trust. How much do we trust to some systems? How much we can trust? It's about reliability. Good. There is a course in Master in Computer Science called Dependability and Reliability. Dependability and Reliability. It's a very interesting course, and in this course you will learn what is a reliable system and what should we do to make a system as to be a reliable system. So reliability, in fact, is about the probability. I mean, it's the probability that a system will do its job or its execution without failure. It is called reliability. For example, the probability that a plane will fly without an accident is given by a number, for example 99%, and it is called the reliability of the fly in our example. So it is reliability, yeah. And some important definitions are here about Dmms. One thing that is very important in Dmms is bandwidth. Bandwidth is, what is the bandwidth? You say, what is bandwidth? Wavelength? No. The amount of data are transmitted in internet. Only in the internet? Rate data through channel. Yeah, it's better. It's better. But what does it mean, rate data? It's better to say that I'm waiting to correct your definition, Mr. Hussein. Search as megabits or kilobytes. Yes, they are units to calculate and to calculate bandwidth or to show some numbers of bandwidth, but the maximum amount of data transmitted. Or better to say, the maximum rate of data transfer across a network. The maximum rate of data transfer across a network. Every network, internet, local area network, or any other network. It is called bandwidth. So it's very important in Dmms. Is it only important in Dmms? No, it's important in all distributed systems, because in all distributed systems we use network to interconnect computers and machines. So bandwidth is very important in all distributed systems area. The another definition is about latency. Latency is important in Dmms and also it is important in distributed system. But what is it? What is latency? No, it's not the response time. The speed, no. Latency. Search about it. Search about it to see what is latency. If you search it, I think you will better learn about it. But please keep in mind that latency in Dmms plays an important role because of the inheritance of Dmms. What issue am I speaking about? What issue am I speaking about? Inheritance of Dmms. What is it? It's about being real-time. Dmms is a real-time system. I mean, Dmms is inherently real-time. So the new question is that what is real-time system? Response without delay time. It's acceptable, but it's not the accurate definition. Response without delay time. Real time between the original and destination. No, it's not a good definition. We will learn more about real-time systems later, or better to say soon. So forget about it. What about loss rate? It's another definition in Dmms, loss rate. What do you guess about loss rate? Thank you, Mr. Zulfaqar. Yeah, loss rate is the frequency with which losses are incurred. In Dmms, loss rate is about acceptable drop frame rate. Drop frame rate. Drop frames, it means missing frames. You know, when you are seeing or when you are watching a video or football match, it consists of some frames. For example, 24 frames per second is shown for you. If some frames are missed, so you see this football match with a low quality. So we must determine an acceptable ratio for drop frames. It is called the loss rate. And quality of service, or QoS, quality of service or QoS is negotiation and allocation of computing resources. Dmms, it's a very good technology, and this technology is a type of revolutionary in challenging manufacturers to rethink many consumer devices. It's about rethinking many consumer devices by manufacturers. How? For example, for several decades, the main home entertainment device has been television. The main home entertainment device has been television. But now, if you think about future, you cannot be sure that what device would be the main home entertainment device. For example, again, the television, or the computer, or laptop, or tablet, or games console. Who knows? We are not sure. Why? Because of DMMS, because of distributed multimedia system. Do you agree? Well, and now I would like to talk about some important points before I continue the lesson. In fact, I had several requests for supervising students' dissertation. Some of your friends sent me emails and requested me to be their supervisor for dissertation. However, because I have severe limitations in time, I cannot accept all the requests. And to be honest, these are my research interests. So please take a look at these research areas and research topics, and if you are interested in or familiar with these topics, then I may accept to be your supervisor. Otherwise, please do not request me, because I'm afraid I cannot supervise your dissertation. The first topic is about real-time systems and real-time scheduling. And the next one, multiprocessor scheduling, embedded systems or critical embedded systems, indeed, dependability, reliability, and fault tolerance, FPGA and scheduling hardware tasks, scheduling hardware and software tasks on a hybrid environment. I mean an environment containing CPU and FPGA, CPU for running software tasks and FPGA for running and executing hardware tasks. And lastly, bioinformatics, especially phylogenetic trees. So, do not request me to be your dissertation supervisor unless you are interested and you are familiar with one of the above topics. Is there any student who is familiar with one of these topics? Is there any student here who is familiar with one of these topics? There is no need to write the topics, you can see them. Here in this slide, you can see these topics. No, image processing is not my research area. I don't have any sufficient experience in image processing, so I cannot help you in image processing. These are the only topics that I have enough information and knowledge. So if you are familiar with one topic, then I can help you. I can help you. Otherwise, I cannot help you. Well, let me continue. It is very important for you, students. It is very important for you to select a supervisor that he has enough knowledge in the topic you are researching on it. If the supervisor has no sufficient knowledge on the topic you are interested in, so he cannot help you, and you should do all the work. You should do all the work by yourself, and it would be very difficult for you to finish your dissertation properly. So it's very important. Please request some right person. You must find the right professor, the right person for your dissertation. Now, here I want to compare two different systems. The first one is distributed system. You completely know what is distributed system. And the second is about real-time systems. Firstly, we must know what is real-time system. Real-time systems often involve time-critical control tasks in which their correctness depends not only on their functionality but also on timeliness. It means time limitation is as important as the functionality of the tasks. Or other definition is that real-time systems are defined as those systems in which the correctness of the system depends not only on the logical result of computation, but also on the time at which the results are produced. It is the definition of real-time system. Is this definition clear for you? We can have a flashback here. Go back to the definition of distributed system. What is a distributed system? A distributed system is a collection of independent computers connected by a network in which users see this system as a single coherent system. Okay, it's obvious and you know. You completely understand. But real-time systems are those systems that not only the correctness of execution is important, but also tasks must finish their execution in a given time, in a predefined given time. Predefined given time. I mean, in such systems, tasks have deadline. Some deadlines are defined for tasks, so every task has a predefined deadline and it must finish its execution before its deadline. This is the meaning of real-time system. So tell me, what is the deadline? What is the deadline? What do I mean by deadline in this definition? I think it's obvious, yeah? I'm sure that all of you know what the deadline means. Yes. For example, I give you an exercise, a homework, and I say that you must do and solve this homework until the next week. It's the deadline. If you do this homework 2 weeks later, it's not acceptable for me because you missed the deadline. You missed the deadline. So it's the meaning deadline. In the system, we have such deadlines for tasks. In fact, deadline is a predefined. We define it before the system begins to run. Before the system begins to run, the deadlines are predefined. So deadline is a predefined time that tasks must complete their execution in that time. How we can run tasks to meet deadlines? It is called scheduling. It is called task scheduling. And what is task scheduling? If we schedule tasks based on priority, so it is a kind of scheduling, but it's not always the rule. For example, round robin is a scheduling algorithm, but it doesn't based on priority. Round robin. Have you heard it? In bachelor, in the course operating system in bachelor, you don't have passed the operating system course in bachelor. In that course, we studied some scheduling algorithms. For example, first come first service, FCFS, first come first service, or round robin. First come first service or round robin. These are scheduling algorithms that we have studied in Bachelor. You must know and be familiar with them. In first come first service, each task that comes sooner, we execute it faster. In round robin, we have slack times. In round robin, we have slack time and time sharing, in fact. So all the tasks are being executed in the slack times. It is scheduling. Scheduling is important because our resources are very limited and we have many requests. For example, there are many tasks. Each task wants to be executed and we have only one processor. So we must schedule these tasks to use this single processor to be executed. For example, in time slack 1, we say that task 1 must execute, and in time slack 2, we assign task 2 to processor and so on. It is a scheduling. FIFO, first in, first out. Okay, good. So you know we had some scheduling algorithms to schedule tasks in Bachelor, but those tasks were not real time. I mean, there were not any deadline. Here in real-time systems, we have deadlines, so we need a new type of scheduling called real-time scheduling. Real-time scheduling is scheduling algorithm for those tasks who are real-time. In the real-time scheduling, we have some important properties. The one thing is deadline. We talked about it. The another important property is about release time or ready time. Release time is the time that a task requests for a CPU to be executed. It is called release time. Worst case execution time is about the execution time of a task, the worst execution time of a task. For example, task 1 at most needs 3 time units to complete its execution. It is called worst execution time, worst case execution time. And the last one is about period, in periodic systems, in fact. Some real-time systems, or better to say, most real-time systems are periodic. Periodic means the system periodically repeats the task. For example, we have a monitoring system. Monitoring system is calculating the temperature of the room every 1 second, for example. So at every second, this task is repeatedly executed. It is a periodic. The period is 1 second here for this task. Clear? I don't want to give you deep information about real-time systems, because it's not a course about real-time systems. We have another course called real-time systems or advanced topics in operating systems, which focuses on real-time scheduling. Okay, but in this course we will focus on distributed system. And now in this slide I want to give you some information, general information about real-time systems, so that you will not confuse between distributed system and real-time system. Well, so we can do an example of scheduling of real-time tasks. It's a very simple scheduling of 3 tasks. In the system, we have 3 tasks, 3 real-time tasks, T1, T2, and T3. The first element, please don't confuse, I made a mistake here in fact. The first argument in the parentheses is about period and deadline, and the second one is about execution time. Okay, so look at this picture. We have 3 tasks. T1 needs 1 time unit to complete its execution. I mean, the execution time of T1 is 1. The deadline is 4. It means after it releases, after release time, after T1 is arrived, we have 4 time units to complete the task. It is deadline of the task. If we cannot complete within 4 time units, then we miss the deadline. I said that this system is periodic, and in periodic systems, usually the deadline is equal to the period. So the period is 4 again. It means every 4 time units this task requests for executing. Every 4 time units. For example, it's a task to calculate the temperature of the room. Every 4 units this task requests to be run, and the execution time is 1 time unit. It means in 1 time unit it completes its execution. 4 time units later, again this task will arrive. Task T2 has 2 time for execution time, and its deadline and period is 5 time units. And task T3 has a deadline of 7 with execution time of 2. Well, we have only 1 processor here, so we need to schedule these tasks to be run. At time 0, all 3 tasks requests, all 3 tasks arrives. It means they want processor to be executed, but we have only 1 processor. We must decide which task must be executed first. We select task 1 to be executed. Why? Because its deadline is shorter. Its deadline is 4, but the deadline of the task 2 is 5, and the deadline of task 3 is 7. So it is better to run T1 first. We assign T1 to the processor. T1 begins to execute, and 1 time unit after it completes its execution here. Here at time 1, T1 finishes its execution. As you can see, the deadline is 4, and T1 finishes its execution before the deadline. Everything seems to be okay. Now CPU is idle. We must select one task between T2 and T3 to select one of them to be executed on the CPU. Again, we select T2 because its deadline is shorter. So T2 at time 1 begins to start its execution. As you can see, it needs 2 time units to complete its execution, and in time 3, T2 finishes its execution. Now, it's no need to select a task because we have only one task waiting to be executed. That is task 3. T3 starts its execution at time 3. It needs 2 time units to finish its execution. So at time 5, T3 finishes its execution. At time 5, we have 2 tasks waiting to be executed. Which tasks? At time 5, we have 2 tasks waiting to be executed. Which tasks, I mean? Look at the picture. It's obvious. At time 5, it is not possible that 2 tasks starts their execution simultaneously because we have one processor here and every processor can handle one task at each time. Task 1 and task 2. We have 2 tasks at time 5 when task 3 finishes its execution. We have 2 tasks in ready queue. They are waiting to be executed. Task T1 arrived at time 4 and task T2 arrived at time 5 because its period is 5. So at time 5, we have 2 tasks waiting to be executed. We must select one of them, and we select task 1 because its deadline is shorter. Task 1 here starts its execution at time 5 and it finishes its execution at time 6 here. Just after T1 finishes its execution, task 2 begins its execution here. And 2 time units later, it finishes execution again at time 8. At time 8, exactly at this time, task 1 again arrives because its period is 4. Every 4 time units it arrives. At time 8, it requests to be executed on the CPU. So the CPU is now idle. T2 has finished its execution and CPU is idle. So task 1 starts again its execution, and so on. It is a scheduling, real-time scheduling. It's a real-time scheduling based on what? Complete my sentence. It is a very simple real-time scheduling based on we schedule based on what? The deadline. Thank you. We select the task to be executed based on the deadline. The shorter deadline, the higher the priority. So this simple scheduling is based on the deadline of the tasks. And it works. As you can see, no task misses its deadline. All tasks meet their deadlines. No miss is here. No miss deadline. If you change this scheduling, for example, schedule it based on something else, not deadline. For example, execution time. The shorter execution time, the higher priority, for example. You will see probably the tasks or some tasks misses their deadlines. We will have missed deadline in this policy. So you can do it in your home. Okay. I don't want to teach you about real-time scheduling. It's not our main subject here, okay? But it is a good idea that you be familiar how real-time tasks are scheduled. In this simple example, we have only one processor, but in some systems we have more processor called multiprocessor system. In multiprocessor systems, scheduling real-time tasks are more complex. They are not easy as you can see here. It will be very complex, and you can find many different algorithms about that area. So scheduling real-time systems could be a good topic for research if you are interested, and I can introduce a book named Real-Time Systems written by Kopets. Professor Kopets has a book named Real-Time Systems. It's a very good book to begin to this to learn this area. However, I recommend you, if you are interested in real-time systems, I recommend you to pass the advanced topics in operating systems or real-time systems scheduling course. It could help you to better understand and learn real-time scheduling. Yes, the book is titled Real-Time Systems, written by Kopets, I think. Let me search it. I'm not sure if I typed it correctly. Kopets, yeah. Herman Kopets, Real-Time Systems. Also, you can search for real-time scheduling books. Real-time scheduling books with this title. Real-time scheduling book. But as I said, I repeat it again, I recommend you, I highly recommend you to pass this course, Real-Time Systems, or the course named Advanced Topics in Operating Systems. In such courses, you can learn completely about real-time systems and real-time scheduling. Well, it's not our main subject in this course, okay? And here are some real-time systems examples. For example, airplane, train, car, satellite, they are real-time systems. For example, in airplane, we have a system to calculate the pressure of the cabin every 1 millisecond, for example. Every 1 millisecond, this system calculates the pressure of the cabin. It's very important for some calculations in the airplane to have the correct pressure of the cabin every 1 millisecond. So, if we miss some deadlines, if this task cannot calculate the pressure in 1 millisecond and misses its deadline, and if we miss too many deadlines in the system, so it may result in a bad accident, it may result in a catastrophe, or it may result in a disaster. Do you know what does the disaster and catastrophe mean? Disaster and catastrophe. People may be killed. It's a disaster. What's the meaning of disaster in Arabic? Disaster, catastrophe. I think it is a faci'e. Karthe, yeah. And what about faci'e? Is it Arabic or not? Faci'e. In Farsi we say faci'e. Faci'e. In this manner. Faci'e. What does it mean? Yeah, in Farsi we say faci'e, but you may use some other words. Okay. So, if in a real-time system missing deadlines results in catastrophe or disaster, this system would be a hard real-time system. Hard real-time system. And the deadline is called hard deadline. Hard deadline. It means we have not allowed to miss any deadline. We must try, we must make every effort to meet the deadline. Missing the deadline results in catastrophe. It's a hard real-time system. But in some systems, for example, when you are watching a football match live, a live football match on the internet, okay, it's a real-time system too. But missing deadlines and receiving packets after the deadline would not result in a catastrophe. You may lose the quality, but it's not disaster. You are alive, and you only miss the quality. This system is called soft real-time. So we have soft real-time and hard real-time systems. Clear? Okay, good. And about real-time systems, I talked about it enough. These are some other questions about real-time systems that you may have. What are scheduling algorithms? What are single processor and multiprocessor scheduling? How about real-time scheduling on multiprocessor? what is a reliable real-time scheduling using primary backup, and many other questions. You can find good answers and correct answers of these questions in real-time systems studying. And now here we have distributed real-time system. You know what is it, distributed system, and also you know what the real-time system is. But what is distributed real-time system? No, it's not important for you to find some answer for these questions. It was just a sample of some questions that you will learn about the answer of these questions in real-time system course and real-time system study. I said it's not our subject here. I only gave you some basic information and fundamental information of real-time systems to you, and so you know what's the difference between real-time system and distributed system. And also I expect you don't confuse between these two systems, okay? Well, and now I'm talking about a new type of system called distributed real-time system. It's a very, very interesting area. And what do you guess about it? What is it? I said you know what distributed system is, and you also know what the real-time system is. And how about distributed real-time system? Yes, in fact, in the real-time system, yes, as you can see, if the real-time computer system is distributed, it consists of a set of computer nodes interconnected by a real-time communication network. It is called distributed real-time system. If I want to give you a good example of distributed real-time system, I can say that you and I, that we are using a distributed real-time systems right now. Adobe Acrobat application is an application for video conference. Okay, I am teaching to you. I am sharing this slide. I am sharing this picture, and also you can see the picture and you hear my voice. So it is a distributed real-time system. Why it is real-time? Because if you don't receive the packets of the sharing image or my voice in the predefined time, you will lose the quality. So we have some predefined deadlines for this system. It is a real-time system, but soft real-time system. Why? Because if you lose the connection and if the packets cannot be received in time for you, it will not result in disaster. So it is a soft real-time system. Yes. Disaster is not only about life. If you lose a huge amount of money, so it will be disaster too. For example, a stock and exchange system is a hard real-time system. You know, also I can say that if some system affect on the environment, it would be a disaster too. For example, a nuclear plant, okay? For example, a plant who produce power from nuclear energy. It could be a disaster if some deadlines missed in this plan. No, because it affects the environment. Or chemical plants. So disaster is about life, is about money, and is about environment. For example, if I don't know, for example, if a shuttle, NASA shuttle, cannot finishes its execution right and correctly, and if it failed, so it would be a disaster, because this project is very money consuming, okay? So it would be a disaster. And in this system we are using Adobe Acrobat. If the deadline will be missed, it would not be disaster. It is a soft real-time system. So, okay, it's enough for today, and we can continue our talk next session. Where is our next session? We want to talk about cloud computing as a utility in distributed system. Good. When is our next session? Yes, inshallah. Next week. Good. So I see you next week, and have a good night, and Khuda Hafiz. What do you say Khuda Hafiz in Arabic? إلى اللقاء. I think you say إلى اللقاء, yeah? Yes, okay. إلى اللقاء وخدا حافظ.